Okay, so good morning. Let's start. My name is Joaquin Hernandez. I'm CEO of PLOCAN, the oceanic platform of the Canary Island. And we are going to talk today about cost-effective wave energy for isolated systems and islands. So islands and isolated coastal systems have special requirements for any supply, and at the same time, we have constraints because the infrastructures or the development of the electrical system. However, those environments could provide also market opportunities, new needs for innovative development, especially on marine energy. So we also believe that these islands are natural test sites to improve technologies and also business plan across Europe. So I think that the islands have to have a more active role within the European Green Deal, and especially also could provide value for technological developers and this roll up of the technologies to the markets. So this is the subject that we are going to focus today, and we are going first to review the situation about marine energy at the European level. We have today with us Remy Colombet, Policy Officer of the Ocean Energy Europe, that is going to provide us a first introduction about that. So later on, we are going to give the floor to Francisco Garcia, that is the president of APA Marina, to take care of marine energy. It's an association in Spain about marine energy. So it's going to give us an update about the situation and the context in Spain. And finally, we are going to close the presentations with Michael Henrichson, that is CEO of Wave Piston, and he is going to introduce a new and innovative device, especially designed for harnessing energy in the islands. And he is going to test just in a few weeks or months here in Spain. So without further introduction from my side, I would like to give the floor first to Remy Colombet, that as said, is a policy officer from Ocean Energy Europe. So thank you very much, Remy, to be with us today, and go on, the floor is yours.
Thank you very much, Joaquin, and thank you for the invitation to speak on this webinar. Before starting my presentation, a quick word on Ocean Energy Europe. We're the largest network of ocean energy professionals in the world. We have about 110 members, some that you might know, ranging from big energy utilities to technology developers, the supply chain, universities, and even regions. During this presentation, I will try to provide a European perspective on wave energy development. I will mainly focus on the economics, as I know that my fellow panelists are much more qualified to talk about the technical side of things. So to start, we can see that wave energy has progressed a lot during the past 2-3 years. Building on subscale tests, we're seeing now a new generation of full-scale devices being tested and hitting the water. Here you see AW Energy's device being tested in Peniche in Portugal. And here is Welo's second penguin that's going to be brought to the BMET Center by Saipem, installed later this year, hopefully. In terms of technology readiness level, Wave is around 7 and is progressing. Now that we can witness very steady growth in cumulative capacity during the past 10 years. Projects are mainly driven by research and innovation opportunities. But we see that there's a variety of development strategies. The classic one is going for utility scale projects, and we know where those projects are going to happen in the next few years. Member states have been told to design national energy and climate plans with targets for each renewable energy technologies. And Spain, Portugal, and Ireland have included targets for wave energy in their plans. Now we're also seeing that there are other opportunities, and islands and off-grid locations are a great laboratory for developing wave energy technologies, as you mentioned, Joaquin, because there's a high electricity price, usually due to the use of fossil fuels for electricity production. Now we are seeing also oil and gas companies going into the wave energy sector and buying or developing their own wave energy converters to decarbonize their oil and gas platforms. Finally, floating wind platforms are also a new market for wave energy developers, as we see combined tech that would stabilize the wind platform and produce energy from the waves. Now, OE has recently launched its vision for 2030. We had the pleasure to welcome Charlina Vitcheva, the Director General from DG Mare, to launch this document that presents two scenarios for wave energy development: a high growth scenario with around 500 megawatts installed by 2030. That would mean a cost decrease around 110 megawatt hours at that time, and a low growth scenario where 178 megawatts would be installed by 2030, and that would lead us to 150 euros per megawatt hour. So we're very confident that there are clear cost reduction paths for wave energy that are mainly based on technology improvements, so PTO efficiency, better moorings, economies of scale, and the development of a custom supply chain. And on the left of this slide, you can see what the ocean energy supply chain could look like in Europe by 2030. Now, one of the main, and maybe the main path to cost reduction is deployments. It creates learnings and allow developers to improve their devices, but also lower costs through scale. And we can clearly see that with appropriate supports and deployments, wave energy is going to be affordable in the next few years. The good news is that wave developers are not alone in this, and there is EU support currently and in the future coming to help develop new wave energy projects. First, there are national recovery plans. As you may know, there's a recovery budget that's been voted during the summer at EU level, extra money on top of the usual European budget dedicated to the recovery post-COVID. And the national governments are currently designing their plans. They have to design plans to be approved by the Commission to receive the money. So now is a good time to talk to your governments and ask them to include wave energy in those plans. Secondly, the Commission is currently designing an EU offshore renewable energy strategy. Now, this strategy was originally an offshore wind strategy. We managed to turn that into a strategy including also tidal and wave energy. And this document is going to be the basis for the Commission support to the sector in the next few years. And we're obviously pushing for efforts on permitting, marine spatial planning, but also investment in research and innovation. Finally, and something that is very relevant, I think, for our discussion today, there's a Clean Energy for EU Islands initiative. It's been already running for a couple of years, and it's an EU design platform gathering technology providers, but also the islands that want to design a transition plan towards a more sustainable future. So this is a good initiative for our developers to meet the local governments, meet partners to form consortiums and launch new projects. So at Ocean Energy Europe, we know that sometimes the EU offer in terms of program funding is a bit complicated. So we've designed this overview that's available on our the members area for websites. It basically gives you all the European programs that are available for ocean energy and wave energy in particular. And just clicking on the name of the program, you'll have access to more information and briefings on those funds. I will focus on two upcoming ones in particular. The Blueinvest platform grants. There's a new call that's going to be launched it's exclusive for SMEs this year on the 24th of November with a total budget of 40 million euros and providing grants up to 2.5 million euros. And it's very well suited for wave projects. And there's also for the view that are a bit more advanced in developing their technology, the innovation fund that will give you funding for small farms and pilot farms. Here was my presentation. I'm happy to answer any question you might have on support at EU level and wave development in general. Thank you very much.
Okay. Thank you very much. Thank you very much, Remy. There's a lot of questions. I also have some questions in related with the legislation, but let's move on to the next presenter, and later on in the discussion we can go through the questions. So our next presenter, our next panelist is Francisco Garcia, that is the president of Upper Marina in Spain. So Francisco, thank you very much for being with us, and please give us a short presentation about the situation in Spain.
Thanks, Joaquin, and thanks for inviting and for being here today with all of you. Can you see my screen now?
Yes, go on.
Okay, great. Then the idea here is that, okay, this is our Spanish overview that could be quite complementary to the overview that Remy has presented right now. Then we think that there is a potential opportunity here, and we think that Spain is well positioned in order to take an important role in the marine energy development. When I talk about marine energy, I'm talking not just about wave tidal, not just ocean energy, but also wind, floating offshore wind. Okay, then the key strengths, as I summarize here, are related to resources, resource and natural conditions, infrastructures, researchers, and industry capability, and the new energy framework with the Horizon 2030. Then this is a brief presentation about the wave energy resource along the coast of Spain. There are 8,000 kilometers of coast here, and this is the study that IH Cantabria did a few years ago for the government, the central government of Spain. And there are plenty of areas where ocean energy is available and can be used in a competitive way. And you can see here on the top left, on the bottom left, the Canary Islands, where there are good resource in the north of the majority of the islands. Regarding the infrastructure and scientific capabilities or capacities, we are talking about different sites and different test labs in real environment, that this is relevant. Here you can see BMEP, Mutrico, then PLOCAN. We have several HARS labs, one just recently inaugurated within the Flotant project at PLOCAN site. The other one in BMEP, HARS lab led by Tecnalia, and the third one, Bocal, in the north of Spain, in Cantabria. And these are indoor facilities mainly related to flumes and wave tanks. We have IH Cantabria, CEIPAR, FENER, FEDEX, some others related to universities. We have experience deploying renewables in our country, and it was done not just based on commercial or business development, but plenty of researchers behind in order to make it happen, and mainly related to wind, solar in the past, and mainly onshore. In addition to that, there are plenty of capabilities related to the marine industry, shipbuilding, ship construction, maritime operations, that can be like a great value chain that can be implemented or adapted to marine energy in the near future. This is what I was talking about, this experience we have with other projects related to energy and maritime industry. And in addition to that, there are strong regional clusters that are very well organized to supply all you need for your project implementation and project deployment. And APA is working not just in Spain, but working hard with Ocean Energy Europe and other European associations and local associations plus clusters in order to make it happen in the near future. And then this is the framework, and this is something relevant. We are talking about the national plans. We call here in Spain PNIEC, Plan Nacional Integrado de Energía y Clima, Energy and Climate Plan, for the next decade, 21 to 30. And what we have been working on, in the drafts that we have been developing, or the government has been developing for the last couple of years, our effort was to have a specific mention and a specific goal for marine energies. What we have now is a specific goal for ocean energies, and there is a goal for wind that should be split in offshore and onshore. But this is something that anyone knows about it, and should be something that can be implemented in a specific legislation once the plan is approved. Then, in addition to that, there is a huge working group where everyone is integrated, every stakeholder related to maritime activities is integrated in order to define the marine spatial planning, to see where we can install our farms, wind, wave, tidal, and be compatible with existing and new uses of the ocean. And last but not least is related to the legislation that we have in place. It's old, from 2007, if I'm not wrong, but it's a good starting point, and can smooth and can make things easier in order to implement faster and simpler new project developments here in Spain. And why islands? This is a good question, but we think that marine energies are going to be competitive and are going to be first in islands and coastal communities and remote coastal communities. And it's a very simple reason, and it's kind of a strategy related to the cost. And when we deal with islands, and we are talking about cost, and the cost of producing electricity in islands is quite expensive. And this is due to energy dependency, mainly on oil in some islands, maybe the majority of the islands. And it's also about logistics, and it's also about security of the system. They have to duplicate the power plants in order to guarantee that every consumer has access to the energy every time. And I've been talking to Joaquin before starting this webinar, and he provided me some good numbers. And Joaquin, if you don't mind, I'm going to put these numbers on the table, okay? Yes. But are yours, okay? We have been talking that recently the government of Spain approved roughly 700 million in order to cover the extra cost of producing electricity in the Canary Islands, not in the Canary Islands, in all the islands around Spain, mainly Canary Islands.
Canary alone.
Canary Islands alone, sorry, good, thank you. Then what we are seeing here is that we are paying an extra cost in order to produce electricity with fossil fuel in the islands. And that's true. No one in the islands can see that because the final price that they receive every month in their invoices are prices similar to the continent. And this is good on the one hand because we are socializing the cost and supporting the cost. But on the other hand, we cannot see the real cost. Is hidden in some way. And then what we need to do is to be able to accelerate the transition from high cost producing energy with fuel to renewables. And we don't want to have any kind of extra subsidy or extra price for renewables. We only want to have the same price as the cost of fossil fuel has in the islands. That's our goal, that's our point. And no one is losing money or getting money because of that. The system is balanced and the proposal is neutral, but it's going to be enough in order to have demo projects in the islands and in order to have kind of a starting point to deploy our devices there. Okay. Some people say, yeah, but this is difficult and this is dangerous because you are going to go for several hundreds of megawatts. No problem. Let's talk about specific goals step by step. And once we demonstrate, we can keep growing these goals in order to make bigger and more competitive and more competitive. And this is where we are. This is why we think that islands are going to be one of the key, key assets in our deployment strategy, mainly because of cost. An example, many of you know this for sure, but this is recent from the World Bank from 2020, and you can see some examples of the price of electricity in different islands. And I'm just using this slide because I think that some of you are not believing my words that cost of electricity in islands is so high, but it's really true. And you can see here Solomon Islands that the cost is over 70 cents per kilowatt hour. That's crazy. This is APA Marina. APA Marina is representing the main stakeholders in the marine energy industry in Spain. We have been working in offshore wind, wave, and tidal since 2015. We have been talking to many people at that time, and no one was listening to us, not just government, NGOs, but also other associations where we talk to in order to team with them. And they say, oh, this is crazy. It will come, but it will take like 10, 20 years. No, it's now, it's there, it's here. Then this is what we are doing in order to speed up the market transition, the market deployment of marine technologies in Spain. Was founded in 2006, and since then our goal is to create a market. And we think that coastal areas and islands are key places to have that. Sorry, to deploy this market. And that's it. Thank you.
Thank you very much, Francisco. Later on, we will discuss more in details. And now I would like to introduce the final presentation. Is Michael Henrichson that is going to introduce a very innovative device supported by the European Union, and that is going to be tested shortly. So Michael, thank you very much to be with us today, and the floor is yours. Michael, I think that you are mute. Michael is the CEO.
Yeah, I'm here. Okay. I'm here. Can you see the screen?
Yes, everything's fine. Goes on.
Perfect. Thank you. Thank you. I'm Michael Henrichson, CEO of Wave Piston. Thank you for inviting us here, Joaquin, together with PLOCAN and the other Guys, I'm going to tell you a bit about wave piston and our view on this on isolated systems and islands, and also a bit about the status we are at right now. So first of all, our team. So we are still a small team. We're up now to 9 full-time and 4 part-time people working on us, and then a professional board, having sort of an experienced team around that's very good. So what we are focusing on, we have two products in what we do is we have the renewable energy, so electricity power based on renewable energy, and then water. So it's a double product. And we focus on waves, that's why we are here today. And we all know that the potential is very large. The problem is, of course, how to harvest it efficiently, and so we need some good technologies that actually do this, show that we can be competitive, and that hasn't been possible until recently. And we claim that the wave piston technology can be one of those technologies that can make wave energy competitive. And those of you who do not know about how it looks like, this is this system. We have many plates placed what we call on a string. So we have all these plates. These are called energy collectors. So they're like modular system, and then with a mooring in each end. And all these things, these energy collectors are pumping up pressurized water for energy conversion to electricity, and also for desalination. And we can place like many strings next to each other, so we have like a modular system depending on what is needed at given location. So just to understand a bit more. So we have these energy collectors. You have the example here. They drive 2 pumps, 1 pipe on each side. So both ways it pumps water into a main pipe. So we have no electrical cables right out in the ocean. So it's a hydraulic system. And this pressurized water up to 60 bar is then pushed up to the shore for conversion. And we have here on the right side, you have the turbines that can convert it to electricity, so power conversion. And we also have this desalination, because we work with pressurized water. We can use that in a reverse osmosis system to do desalination. So that is sort of the products we come with. And why is this interesting? Also seen from an island perspective, of course, one thing is this about where some of my colleagues also talk about this. One thing is with the cost of things, but also the value of the energy. The wind and solar and the cost of that is extremely low now, which is very, very good. We need more. And that's why we say, okay, we need waves also, because it can complement wind and solar power. And also, as you know, many of you, that we can produce power at different times than wind and solar, because it's time-wise shifted of these things. So the value of energy is also very important here. Second thing that is interesting when you look at the ocean energy side and wave energy is that we do not spoil the view. So it's more non-intrusive system. We call it here. Many places that we go to islands and remote locations, you cannot put wind turbines up for different reasons, or there's not enough land on this. So wave energy can go in and be this complementary energy source, these places. And then looking at our solution, where we have both electricity and water, and in these smaller systems and microgrids, etc., it's important for this. We can make a higher efficiency of the system. We can dimension it better, because when there is surplus of energy in the wave, so the consumption is lower than what we actually can produce, it is relatively easier or cheaper to store water, so we can produce more water when that is needed. And then it's only when there is like under production as such that we need some other solutions. Could be diesel, or could some battery or whatever to cover those things. Or if we combine it with the wind and solar, then this complementary thing is actually reduced. So we're working with these very important sustainable development goals, the 6, 7, and 13. So energy, the water, and the climate action part of it, which is also important when we look now on how to get, support and financing going forward. So where are we now? Just look a bit back in time. From 15 to 19, we have been testing in the North Sea, different test iterations, sizes of our system. We call our prototype system. So here's a picture of installation in 17. We've been out installing and replacing energy collectors, getting a lot of experience with that. And latest, we had this installation end of November or end of 2018, and then 19, where we had our last sort of installation in the North Sea. So that is finished. We have our prototype phase finished, and now we are focusing on our demonstration phase. And where we are now in the warm embrace of Joaquin and his people at PLOCAN in Gran Canaria. So we're going to install a system there, our first full-scale system, where there's two projects actually, and the first project is only focusing on the power generation, and the second project where we also can install another string, where we're going to be this combined solution of both power generation and desalination. And for these projects, we have received grants from the EU. They have SME phase 2 instrument there, and the Fast Track to Innovation. So we have 5.5 million euro in grants there. And the total project for our total phase here, that is approximately 10 million euro. And we are very happy to get these grants, of course, because it's quite competitive to get this. So that's ongoing. These two projects are our main focus right now. The ambition is to get an installation that will have a peak around 200 kilowatts for one string. So it's 24 energy collectors. We'll get that out next to the PLOCAN platform, get the pressurized water to the platform, and add the power conversion. A similar system like this, if it was only water, would be 150,000 cubic meters of water we could produce, desalinated water. In the project we have this combined solution. We have a dimension for 28,000 cubic meters per water per year. That's what we need to show in the project. So we have already assembled other things, but it's not the final system. We have sort of pushed in what we call a pre-installation, because it's a big step for us going from the prototype, half scale, quarter scale, some places for half scale, and then up to a full scale. So we want to test a few things first. So we have 2 energy collectors we have assembled, tested, and also now we will put in the water actually tomorrow. It's lying here in the port of Las Palmas. The system buoys, which doesn't have anything, they only have the buoyancy and keep the system stretched, so in pre-tension together with the mooring. And we have 2 energy collectors that will be installed hopefully next week, if weather and vessels, etc. allows. So that's very exciting, and this is what we call pre-installation, is to test different types of different parts of the components on the system, and then next year the full installation will be installed in the summer 2021. So that's the plan. Okay, so looking from a commercial side, okay, we can take, we all know this is very large. Also looking at both the renewable energy investments are very high. You have also very high investments in desalination plants, new desalination plants. There's a large growth, so it's very good, but also very competitive market. So to coming in with a new technology and not starting with this utility scale side, we need to focus on something else. And that is why we have this 2-step approach to get into the market. And that's this about, let's focus for first what we call like small scale systems, relatively small scale, for islands, isolated communities, etc. And this is, as we also just heard before, Francisco saying, they have a very high price per kilowatt hour. Actually, Rainer Lemoyne Institute in Germany, they were looking at islands between 1,000 and 100,000 inhabitants, and where that the average price of the diesel generators power is 38 euro cents. And many of these places also have a very large water scarcity. So this is a very interesting market, and we're already in contact with a lot of these different places, and to prepare for the next coming projects after this phase, what we call the commercial phase, so to speak. And then after we have had this, so this is like the stepstone going into the utility scale market, then we can go there. But we first need to get experience with it, get the first system out before moving into this very large utility scale market. But this is we need to focus on the islands first. That's where we believe the stepstone is. Okay, so coming with a new company, we are relatively new. We have a new technology, new sector, and a new market, or it's an established market, but coming in with wave energy, then it's of course not something you just do like this, even though you have a good technology, a good product that you have shown in some tests before. So that's why we are very depending on getting sort of this support in the first, what we call like pre-commercial project, where Ocean Energy, as Remy also mentioned, are very into this, ensuring that we get some support on these, both to get the right financing to support this, because we cannot get the customer to take the risk on the first projects, because everything is new here. So we need to get the proper financing, then we need to proper revenue support. And then we have all this was mentioned with the legislation, that we're getting the, you know, an easy step towards getting permissions to put system in the water. And also insurance of these things. It's also pretty expensive right now. So there are several things that are also needed besides the actual good technology to get to the commercial phase. If I have just a few minutes more, I'm just going to show you why we are saying we can be competitive, because we've just looked at the reference site, the Gran Canaria, because we have a lot of information about where we are at PLOCAN. And just as that's a modest energy area for looking at from wave energy side, but we have all the details. So we place the system there, and it's a 70-string system that's 15 megawatts. So some people think it's big, but it's from a utility scale point of view, it's not. And then put it out there. Then we have our sort of energy tool that we have simulations. How much can we produce? This is what we need to show now with these systems that we are installing in PLOCAN. Of course, we need to validate that, but that's how it looks right now. With all these assumptions on our efficiency, etc., then we can actually calculate saying, okay, we in a system like this, for the first ones, the first system coming out, we have a levelized cost of energy of 20 euros and then a cost of water of 1 cubic meter. But this is what we need to show now. So we need to show results. That's very important in our sector, not just talk, but results. And then in 2022, you need to come and knock on me and on my door saying, Michael, have you shown this or not? But that's the purpose of what we're doing right now. And that's also how and why we can get into this market also on the islands. Okay, so summing up, we're focusing right now on these full-scale pilot projects to sort of validate, to create these results and prepare these first commercial or pre-commercial projects. And then we move into this island, coastal communities, hotel resorts, etc. That is what we're looking at. And then first, later on, we can start opening up the utility scale box. That's our sort of strategy. Thank you.
Thank you. Thank you very much, Michael. So now we are going to start a small debate. We are going to stop at 12 London time or Las Palmas time. There are already several questions, but I just going to introduce you some of them. Someone is asking about how much electricity is produced or is consuming the islands. So is about 9,000 gigawatts hour per year. Well, the date is around 2018, and the extra cost, the almost 700 millions, the overcost was recognized for the year 2015 last October. Is have some delay. But anyway, if someone is interested, we can give you the numbers. So I think that it's quite important to divest the subsidies that we are now pushing. I mean, we are getting on the production with diesel to renewables. So that is something that I think the Green Deal should help us to move and to divest supporting oil production to renewable, especially new devices like the one that Michael has shown us. So these answer some of the questions, but I have some also for all of you. One question is, which are the main drawbacks for implementation 100% of energy systems in the island communities, especially in Europe? So who could answer that? Remy, perhaps you?
Well, there's not that many drawbacks actually that I see to transitioning to renewables. It's actually safer usually. The only issues you have when you want to go to renewables are permitting and sometimes incumbent utilities that want to prevent you to switch to renewables in European islands. On top of that, as you mentioned, islands are usually very willing to transition, and it's now more and more acknowledged by the political level and I'd say the EU level, and more funding is made available for those islands to reduce the costs of the transition.
Thank you. So I have another question saying that the wave energy seems that have a low hours years of generation. What is your opinion of these? Any specific study on the potential has been done for wave energy in the Canary Island? Perhaps Francisco, do you like to take that one?
Yeah, okay. The study I mentioned in the presentation was done by IH Cantabria in 2010, I think, 10, 11, and it's a public document that you can find at IDAE webpage, idae.es. IDAE is a government entity, and if you look for IH Cantabria Wave Energy Resource Spain IDAE, I think that you can find it. And if not, send me an email and I can send you the link.
Okay, so I have another question. Depending on the wave system used, it could happen that extracting energy from waves will impact to surfing spots in the north of the island. Have you checked this impact? So maybe Michael, do you like to answer that?
Yes. Hopefully, of course, we will not put a system just next to where the best surf zone surfer will be. That's definitely not the case. So we haven't. There's like no, not from our point of view side, saying okay, if depending where you put the system, how will that impact the coastline? There has been some. No, I know there's been some studies done in the North Sea by DHI Group, and they say that's not no particular impact depending on where you put it in the water. But of course, it's important that we put the systems in the water where we do not disturb other like touristic activities, etc. Could I just but that's important. So it has to be done looking at fishery, tourism, etc. So everything goes together of these things. Just there was this. Could I just reply on the question about the production in the Canary Islands? Because I have a maybe I can just share. I have a because we have of course looked at that. So if we just share the screen.
Okay.
This is like the production over the year in PLOCAN over 3 years. So there are of course a few months where there's not that much, but actually it's very, very stable there. Looking at the wave climate there in the Canary Islands and over the year. So this is actually one of the very good places to go and put up a wave energy farm.
Thank you, Michael. So I have another question. Do you know about protected areas, SEC, Natura 2000? There are limitation to place marine energy farms in Gran Canaria due to this. Have you considered it? Is there any possibility to negotiate with those authorities? So Francisco, would you like to answer that, or maybe I also give some inputs?
Let me add a specific point, and then you can go with your input. It's related to the spatial planning, and this is an exercise that the main stakeholders in Spain related to the ocean are working on it right now. And in this document, they are taking into account different aspects, not just environment, but other uses of the ocean. And then it's very important to be there and to be active in this process, because if we cannot get a specific area or specific areas for marine energy, we are going to have a significant problem in the future, because if we don't appear now, we are not going to have room for the future. Sorry, Joaquin, go ahead.
Yeah, no, completely agree. I think that these are essential to synchronize. I mean, to work together with marine spatial planning, because otherwise we are not going to achieve the objectives of the Green Deal and also the offshore strategy for energy. So in the Canaries, 40% of the marine space is protected in some way or another. But there's plenty of areas where the activity could be compatible. And also, of course, in some areas, even in protected areas, the nature of protection for the ecosystem is compatible. But anyway, let's start first outside of those areas. And let's see how the things going on. So what is important is that the legislation will be clear, and that we can have a stable legislation with the risking the investment that will be necessary for those investments. So I have another question. In relation with what kind of support do you think that the industry, marine energy, should get in the next years to roll out to the commercial phase? So perhaps Remy, do you like to answer that?
Sure. We've made an assessment together with ETIP Ocean, the European Technology and Innovation Platform, recently. And we've seen that to get to this industrial rollouts where it wants to be, there would need to be about 300 million euros coming from the EU level, about the same coming from the national level, and this would generate investments about the same amount of money from the private sector. So this is not a huge amount of money to create a new industry in Europe. Okay.
So
one comment, Joaquin, related
yes.
to this, if I can add, building on Remy's comment, and what is incredible is that we are talking about LCOE goals in 2025, in 2035, if I'm not wrong, and 2030 for wave and tidal, and when these goals appeared first time, were no any specific goal in terms of megawatts installed. Now someone is talking about that, but at the beginning there were no goals. We need contracts, we need deployment, and as Michael is doing now with Wave Piston, we need deployments, and those deployments, you know well, Joaquin, are not cheap, are quite expensive, and in order to get there, we need to get success and failure, but we need deployments in the ocean in order to increase the number of kilowatts and hopefully megawatts in the next 3-5 years, and in order to demonstrate that the LCOE can go down. That's the goal we need. We need contracts, and that's important. We need to change our mind from subsidies that are really good and we need it to contracts. And if we are able to get that, we are going to demonstrate that LCOE can be reduced.
Thank you. I have another question in relation with PPPs, public pre-competitive purchase. So do you think that this could be a mechanism that could speed up or enhance the development of the technologies? Michael, what do you think about that? The fact that the government could also help provide, just buying the first devices and prototype with public interest.
Yeah, that's one of the sort of the tools that we need, and that's also what Ocean Energy is working on. That is revenue support. You can also say these things. So there's we need to play on several several what do you call it, instruments here. One is the revenue support to ensure that. It also this we talk about marine spatial planning and the insurance and all these things, getting that in a part of these things. And then it's also this of getting the financing, the funding. So if you get these revenue support and the financing for the first project, then the ball starts rolling. Of course, it is a bit of doing what has been done before in wind and solar, but hopefully we can do it a bit faster now. We know we have the experience there, and we believe we do it faster. And as Francisco very well is saying, is that we need to get the systems in the water. We need to deploy. We need to fail. Some will fail, some will go, but of course a lot of will fail. But that is the way we are right now. We are still in this competition right now to finding out what will be the dominant design, what will be the right solutions to make this competitive. But we need to get things in the water there now.
Thank you. I have another question about the challenges that the dispersed market of island could be for providing a high quality and competent sales, after sales support and maintenance and operations and this kind of thing. So do you see or do you foresee any kind of drawback taking into account that the market of the island could be dispersed all over the world? Who can like to take that one?
I just need to understand the question. So on the operation and maintenance, what was the drawback? Sorry.
I guess that what they say is that if you sell all the devices in a well-located area and well-connected and so on, it will be much easier to provide maintenance or operations or after-sales services or these kind of things. But if you have to sell devices in several kinds of islands, Indonesia or places like Philippines or that are isolated, if that could be challenges for the maintenance operation, I guess that could be depending also of the complexity or the requirement, the infrastructure requirements that you need.
Exactly. So that's actually what we try to build in our side in the design. So we make it as low tech as possible on the also of operation and maintenance. So we don't need to fly in experts for operation and maintenance. It has to be done locally. Otherwise, it doesn't make sense, these things. So to build a system that can be transported in an easy way to the logistics sites to get it to those areas because it's remote areas, and also to local operation and maintenance if possible, and also being able to install by local means. So that is sort of has to be the guiding principles in systems like this for islands and remote areas. So that's what we actually striving for to do.
Thank you. And the last question is, can be cheaper to use combined wind and wave systems that wave energy devices only? Would like to take that one?
I can start, maybe you others are welcome to. Definitely. So to share infrastructure is always nice. So that's actually as we are also a Danish company, we also have a Gran Canarian company, but here in Denmark, we've discussed it because they want to make these energy islands in the North Sea. And they are, as you know, in Denmark, they only think wind, and we try to put in some waves there to the politicians. It's difficult, but it's opening a small. So by combining this, because then we already have the electrical infrastructure there, just to add on the waves there, it's like a very small extra investment. So the main investment is to get the infrastructure there, and then we can sort of piggyback on that.
Okay, so thank you very much. We are going to close now. Yes, small message. I think that the islands could offer great opportunities and European assets for helping to develop the technologies and also to start with the business models. I think that we need the devices producing, learning from doing in real work. So I think that if we just use the support or just a little bit of the support, divesting these subsidies to the production with the oil to research, I think that we can accelerate and we can give also new opportunities in the islands to the wave energy industry. So thank you very much. This is just the beginning of this series that we are doing from PLOCAN. So in the next weeks, you will have more information about what we are doing around here. So thank you all and see you soon. Bye.